Okay, so today's lesson, we're gonna move from equations, and we're gonna start looking at inequalities. And as you're gonna see, inequalities, the way that we solve them and what we do to work on them is very similar to solving equations. But there is one extra thing that we've got to do, and the title kind of gives that away: graphing the solution set. So we're gonna get an answer, and we're actually gonna be graphing that answer along with just solving our inequality. So there are a couple new vocab words that we need to get down. So the first one is an inequality, and that is a sentence, a mathematical sentence that it compares two quantities using inequality symbols. And then we've got solution set. And so you pause the video if you need to, go ahead and get these down. So an inequality is going to be set up the same way as an equation, except an equation, all that we had was an equal sign. It was, 2x plus 4 equals 5, something like that. For an inequality, there could be 4 different types of symbols that we use instead of an equal sign. And so there is a greater than, that is a greater than. There is a less than symbol. So this is greater than, this is less than. And then there's also going to be greater than or equal to. And then the opposite of that would be less than or equal to. With these symbols, we treat them as if we were actually reading. We're going to go from left to right. So if the greater than piece is on the left-hand side, so notice the greater than means it's opened up. So if the open side, the greater than side is on the left, that would be greater than or equal to. And then if the less than side, that's the closed part, is on the left, that would be less than. So it's important to know the names of these so you can write the correct one. Also, if you look, there is a line underneath the equal to. So that means it could be greater than, or it could also be equal to that number. And so I'll explain a little bit more with those two as we do some examples. And then the other difference is whenever we were solving equations, we just got a solution. It was just one number that was the solution. Well, for inequalities, we're going to get what's called a solution set. A set is a collection of numbers. The reason why it's a solution set is because it could be an infinite amount of numbers. So for example, we get a solution set, it would be something like x is greater than 3. Well, there are an infinite amount of numbers that could be greater than 3. 4, 5, 6, 4.5, 7.6, 8.3. Those are all numbers that are greater than 3. And so a solution set would be any number that is greater than 3. Or another one would be if x is less than or equal to 7. Well, that would be any number that is less than 7, or it could also be equal to 7. So 7 and anything less than 7. And so there's not just going to be one answer when we do inequalities. There could be many different answers. We write that as a solution set. So that's the difference between equations and inequalities. So a few other things about solving inequalities. We're going to solve inequalities the same way that we solve equations. So think back to the past 2 weeks we've been solving equations. We want the variable on one side by itself. To get rid of a number or a coefficient, we do the opposite operation. If we do something to one side, we must do the same thing to the other side. One difference, though, like I just mentioned, is that we're going to get a solution set for our answer. It'll be one of those inequality symbols, not just one solution. And so that is going to be a difference between solving equations and solving inequalities. Moving on, we're also going to have to graph this solution set. And so we graph the solution set on a number line. Graph the solution set on a number line. So we're going to be graphing a circle at the answer, or at the number that we get. And then we're also going to be shading that line based off of, is it greater than or less than? So if the sign does not have an equal sign, for example, if it is less than or greater than, then we place an open circle on that value. Okay, so an open circle would just be a circle like that. So we place that on that number on the number line. If it's one of those two signs, we place that sign, that circle, an open circle on that number. If the sign has an equal sign with it, in other words, if it is less than or equal to or greater than or equal to, we use what's called a closed circle. A closed circle would just be a circle and then we shade it in. So closed circle means we shade in that circle. Open circle means we just leave it open, not filled in. And I'll explain what those mean, why there's a difference between an open circle and a closed circle when we look at some of our examples. But that's the first thing that we do. We place the open or closed circle on that number that's in our solution set. And then we've got to shade our line. So shading our line, if the variable is less than the value, we shade the number line to the left. So less than means to the left. One thing to remember, L less than, L left. That's the easiest way to remember. Less than, shade to the left. If it's greater than, if it's a greater than sign, then we would shade to the right. So not only are we going to be solving these inequalities, but we're going to have to go one step further and also graph the solution set on a number line. So let's start off by looking at a couple of examples. So like I said, remember, we're going to solve these the same exact way that we solve equations. And so I've got x plus 3 is greater than 10. I want to get rid of that plus 3. In order to get rid of the plus 3, I'm going to subtract 3 on both sides. The plus 3 and minus 3 cancels out. I'm left with x is greater than 10 minus 3 would be 7. So I'm going to write this solution up here. And then I'm also going to graph the solution set underneath. And so I'm going to draw a number line. And one nice thing about this number line is that I don't have to start at 0 in the middle and count over 7 times. I'm just going to put the number 7 right here in the middle. Now, we've got to do two things. The first thing is figure out, is this an open circle or is it a closed circle? That's where you look at the sign. Okay, this inequality sign is just greater than. There is no equal line underneath. Since there is no equal line underneath, it is an open circle. Okay, so an open circle at 7. Then we've got to ask ourselves, do I shade to the right or do I shade to the left? Well, x is, remember we read from left to right. And so x is greater than is facing the left, x is greater than 7, greater than, all the numbers that are greater than 7 are over here on the right-hand side. So just think of it as a number line. 8 would be here, 9 would be here. Those are numbers greater than 7. So we would shade to the right. Now, one thing about the open and closed circle, so the open circle means that 7 is not included in the solution set. In other words, is 7 greater than 7? Well, no, it's not. 7 is equal to 7, but 7 is not greater than 7. So this open circle means that our x could be any number bigger than 7, but it cannot be 7 itself. And so that's why it's an open circle. If it was equal to 7, we would shade in that circle, okay? And that's what we're going to see here on this next one. So I've got n minus 5 on the right-hand side. To get rid of that minus 5, I'm going to add 5. And that's going to cancel those out. So I'm left with n, and the less than is facing n, and then negative 6 plus 5 would be negative 1. So negative 1 is greater than or equal to n. I'm going to write that solution set right here. Now, one thing that I want to note as we graph our solution set, so we'll go ahead and put negative 1 there in the middle. If you were ever taught when graphing these inequalities, if you were ever taught to shade the way that the less than sign is facing, so notice how this sign is facing towards the right, the point is facing towards the right. If you were taught to shade the direction that it's pointing to, that is incorrect. I want you to forget that you were ever taught that. because in this example, even though the sign is facing to the right, we're not going to shade to the right because the less than is facing the in. So first thing, this is an equal to, it's got a line underneath, okay? This sign is equal to as well. So at -1, I'm gonna shade this in, I'm gonna put a closed circle. So if there's a line underneath that inequality sign, I put a closed circle. Second thing is I want you to notice that -1 is greater than or equal to n. -1 is greater than or equal to n. In other words, n is less than or equal to -1. N is less than or equal to -1. You notice what I did? If I move n to the other side, I've also got to make sure the less than is pointing towards the n. And so since n is less than -1, I'm going to shade to the left. So sometimes they're going to try and trick you. They're going to put the variable on the other side that we're used to seeing it on. If that's the case, you've got to ask yourself, okay, what side is n facing? N is facing the less than side, so that's why it's going to be less than -1. I shade to the left. Okay, let's do a couple other examples on our own as well. So that next one, a plus 1/2 is less than 2. I want to get rid of this 1/2. I'm adding 1/2. So in order to get rid of, if I'm adding 1/2, I need to subtract 1/2. Do that from both sides. Okay, so the 1/2 minus 1/2 cancels out. I'm left with a is less than 2 minus 1/2 would be 1/2. And so that's my solution set. Finish solving there. A is less than 1/2. So I'm going to go and graph that on a number line. Now, you might see sometimes 1/2, that's right between 1 and 2. So I'll put 1 right here and 2 right here, which means 1/2 is going to go right in between them. A is less than, there's no equal to sign underneath that inequality symbol. So A is less than, I'm going to keep an open circle at 1/2. And then since A is less than means we shade to the left. Less than, shade to the left. So that is what my solution set graph is going to look like. Okay, and then our next one here, x minus 4 is less than or equal to 6. So to get rid of the minus 4 that's on the side of x, I'm going to add 4 to both sides. So those minus 4 plus 4 cancels off. I'm left with x is less than or equal to 6 plus 4 would be 10. So we'll go ahead and write that here. X is less than or equal to 10. So when I graph that on my solution set, at 10, it is less than or equal to, the equal to is underneath, which means I need to draw a closed circle at 10. 10 is included in that solution set. And then x is less than 10, so less than means I shade to the left. So this means that x could be 10 or x could be anything less than 10 because it's less than or equal to 10. Okay, so with solving them is the easy part really because it's the same thing we do with equations. But graphing that solution set, we're just taking it one step further. So go ahead and do these two on your own. Pause the video, do these two on your own, and then we'll check them together. Okay, so this first one, h plus 4 is less than or equal to 4. To get rid of that plus 4, I will subtract 4 on both sides. So 4 plus 4 minus 4 cancels out. I'm left with h is less than or equal to 4 minus 4. So remember, we had an equation last week with the two-step equations that was like this. If it's 4 minus 4, remember, I don't just stop, and that doesn't mean there's no solution. I get 0. Well, are there numbers that are less than 0? Yes. Is there a number that's equal to 0? 0. So this is still a solution set. I don't say it's no solution. I don't stop. I don't need to do anything else. H is less than or equal to 0. I can still graph this solution set. 0 is going to be right in the middle. Less than or equal to means it's a closed circle at 0. And then there are numbers that are less than 0. Any negative number is less than 0, which means I'm still going to shade to the left of 0. So shade to the left, and there's a closed circle at 0. So that would be my solution set. Okay, and then our last one there, I've got a 0.4 that I need to get rid of. And this is a positive 0.4, which means I need to subtract 0.4 from both sides. And that's going to 0.4 minus 0.4 cancels off. Y is greater than 7 minus 0.4 would be 6.6. So that's my solution set. Y is greater than 6.6. So on my number line, just for a visual, I'm going to put 6 on one side and 7 on the other. And 6.6 is in between, close to halfway, but just a little bit closer to 7. Y is greater than, so there's no equal to sign, which means it's going to be an open circle. And since Y is greater than 6.6, greater than means we shade to the right. So I'm going to shade this line to the right. So that's what my solution set and the graph will look like. All right, we're going to do one more question, and that involves writing inequalities. So writing inequalities, for right now, we're just going to focus on questions that look like this. So it says 4 more than a number is more than 13. So first thing, whenever you see a number, that will be X. And anytime you see the word is, that means equal to. So we're just going to go right in order of what this, how this is reading. 4 more than a number. If I am giving a number 4 more, in other words, I am adding 4. So 4 plus X, 4 more than a number, is more than, I'm sorry, I was thinking about equations. Is does not equal to. You do not want to write that. I got ahead of myself there. You don't want to write is equal to because this is an inequality. So we're not going to have an equal sign. I was thinking of writing equations. Okay, so more than 13. Well, what inequality sign would be more than 13? Well, it would be greater than 13. All right, so forget the part about is equal to. I messed up on that one. We would have 4 plus X is greater than 13, because of this more than. So more than means greater than. And then we'll go ahead and solve this. So to solve it, we would want to subtract 4 from both sides. Going to cancel off this 4. It's going to be X is greater than 9. If we were to graph this, would it be an open circle or a closed circle? Well, it would be at 9, an open circle. And then if X is greater than, will we shade to the right or to the left? We would shade to the right because X is greater than. Okay, so we don't have to graph that one, but that is writing and solving an inequality. And remember, we don't want an equal sign. It'll be one of those 4 inequality symbols that we talked about at the very beginning. Okay, so that is solving inequalities and graphing the solution set, the first kind of thing that we do with those. And so here are the practice problems to work on. There might be some questions that want you to solve it a different way than what we did. So you don't have to worry about that. Just solve the inequalities, graph the solution set on the number line, and then that'll be good enough. So if you have any questions, be sure to let me know.